Hello everyone. Let us look at more examples for Form 1. So let us do integral of cosine cube x sine cube x dx. So as you notice, uh, both the exponents of cosine and sine are odd. So we can just choose between the two which one we will factor out, so we can reserve it for our du. So let me reserve one sine or factor out sine together with dx. So I'll just copy cosine cube x. Factoring out one sine, I'm left with sine square x. I'm doing this because my plan is to reserve sine x dx for my u. So let me write that here. I'm planning to have something du in the form of sine x dx. So if that is the case, my u's must be cosine x. Okay, let's review. If my u is cosine x, then the derivative of u must be negative sine x dx. So let me reserve that here. Okay, so if that is the case, I will have here integral of, I'll just copy cosine cube because all cosines will be replaced with u. So just copy cosine cube x. This sine square, I have to replace that with an expression in terms of cosine. And we know that sine square x is equal to 1 minus cosine square x by the Pythagorean identity. So I will have here, I will replace sine square x with 1 minus cosine square x. That's it. And copying sine x dx. This was what I reserved a while ago. Now, finally, doing the substitution, I have integral of u cubed times 1 minus u square. Sine x dx here is negative du. Sorry. So from there, I have to solve for sine x dx. This should be negative du. Okay. Continuing, I can actually distribute u cubed. So I have u cubed minus u to the fifth. Integrate with respect to du and I'll factor out negative 1. So the antiderivative is negative u to the 4 over 4 minus u to the 6 over 6 plus c. Therefore, I have negative 1/4. Substituting back u, my u is cosine to the 4th x plus, because I have a minus outside, so plus 1/6. U is cosine to the 6th x plus c. This is now the final answer. Okay, let's proceed to another example. Integral of cosine cube x sine to the 4th x dx. So as you can see, only the exponent of cosine is odd. So of course, kaniyang atong i-separate. So I have cosine. If I will factor out one cosine, I'll be left with cosine square x. Copy sine to the 4th x and write the cosine x that I reserved for du. So I'm doing this because my plan is to substitute du to cosine x dx, the one I separated. So if that is the case, all the remaining expressions must be sine of x. Let's review. If u is sine x, derivative is cosine x dx. Let me enclose that. So I will repeat, everything else except du must be in terms of sine. So in other words, I need to replace cosine square. And I know that cosine square x is equal to 1 minus sine square x. So I have here integral of 1 minus sine square x times, let me copy sine to the fourth x and cosine x dx. So therefore, I have integral of sine to the fourth x. Oh, sorry. Actually, you can already proceed with a substitution here. Substitution, I have 1 minus sine is u, so u square times u to the fourth. And this cosine x dx is just du. Okay. Multiplying, I have u to the fourth minus u to the sixth du. The antiderivative now is u to the, okay, u to the 5 over 5 minus u to the 7 over 7 plus c. Substituting back u equal to sine x, I have 1/5 sine to the 5x minus 1/7 sine to the 7x plus c. Okay, that's it. So see you in the next video for form number 2.